If you draw a single card from a standard deck of 52 cards, what is the probability that the card is either red or a face card, or both? Alright, so let's first figure out the probability the card is red. I'm going to pull out my my dice chart here. So a red or a face card or both. So the probability it's red, or the event that it's red, means you're getting one of these cards. The event that it's a face card means that you're getting one of these cards. If you're talking about the probability that you're getting this one or both, what we're talking about is the union of these two events. And so what I'm going to do here is I'm just going to use the union rule. Alternatively, I could go through here and count up the individual cards and say 1, 2, 3, 4, all the way up through 26, 27, 28, 29, 30, 31, 32. I expect to get 32 out of this, but I'm going to use the union rule anyway. So in order to talk about these events, I want to give them names. I'm going to say that E is the event that I draw a red card. F is the event that I draw a face card. So N of E, the number of cards that are red, well, this is 26 out of 52. F, the number of cards that are face cards, is 12 out of 52. And N of E intersect F, this is the number of cards that are both red and a face card. That they're both, they're in both of these. This is going to be 6. This is the Jack, Queen, and King of hearts and diamonds. So there's 6 cards. Oops, I said these are N's. These should be... I was doing these with probabilities, but really I probably should have been, since I wrote N of E, I should be saying 26, 12, and 6. So N of E union F is going to be 26 plus 12 minus 6. This is my union rule. The size of the first set, which is 26, plus the size of the second set, minus the size of the intersection. And when I add these together, I get 32, it looks like. So therefore, the probability of E union F is going to be 32 out of 52. And I could reduce this. When you're talking about a deck of cards, since we see these things so often, it is kind of convenient to memorize a little bit of information about 52. Well, we already know that 52 is made up of 4 suits that have 13 cards in each of them. It's 4 times 13. And so if you're talking about the prime factorization of 52, it's really easy to find. 2 times 2 times 13. Those are the only numbers that can cancel with 52. These are the only prime factors, I should say. The prime numbers that can cancel with it. So when I'm looking to reduce something like this, I know I don't need to bother checking anything higher than 4 here. So I'll get 8 out of 13, because 4 goes into both of those. 4 times 8 is 32, that's where I get the 8 here, and 4 times 13 is 52. So I get 8 out of 13 if I'm reducing this. If you're dealt a single card, what is the probability that it is a heart or a 3? Let's see, I already used E and F, so I'm going to go with, whatever, I'm going to reuse E and F. It is a heart, I'm going to call that E, and a 3, I'm going to call that F. So N of E, the number of cards that are heart cards, well, there's 13 hearts. There's 13 cards in each suit. So we get N of E is 13. The number of cards that are 3s, N of F, there's 4 different 3s. There's the 4 of, well, each of the 4 different suits. N of E intersect F. We're talking about a card that is both a heart and a 3. Well, there's only one of those. That's the 3 of hearts. And so if we want to use the union rule here, N of E union F is going to be 13 plus 4 minus 1. And that's equal to 16, I guess. And thus the probability of E union F is 16 out of 52. And again, I can reduce this. It looks like there's only 4 that can cancel, so I get 4 out of 13 if I reduced it.